Okay, so picking up part 2 here of homework 9-1, we're picking up questions 10 and 11. Those are the last two we have to finish out. And question 10, I would hope is pretty easy. They give us two different position functions, and they ask us what is the superposition right at each of these positions and times. But again, that's pretty easy. All I have to do here is I don't even have to mess with getting just a single function, right? I can just literally take these two equations, plug in the numbers, and then add the two y values together, right? So y1 plus y2, just a matter of plugging it in and calculating. The only thing to watch here is make sure you're, of course, in the right mode. We do want to make sure we're in radians anytime we're working with these functions. So make sure you're in the right mode. But you guys can certainly, I think, follow my work from here. So I don't know that I need to explain much more. I just plugged in the values they gave me, and I calculated the resulting superposition of the waves right at those three locations. So feel free to pause this if you need to look anything over anymore. But I'm going to keep moving on with this video because I don't think that question is terribly difficult. Question 11, however, is a little bit trickier, right? So this question probably is a little bit trickier. I'll go ahead and scroll down, so if you want to check your answers, right, if you've already got those answers and you're confident with them, feel free to stop, but I will offer some explanation as to my work here as well. But anyway, so they give us two functions again, right? The difference this time is they want us to ultimately write the standing wave function that results in the two waves. So that's actually the part I did first. I think it's easy to find the amplitude and the frequency, right, once we've identified our wave function. So that's going to be the part that I do first, right? So I represented it just as y1 plus y2, right? Rather than using just the equation as verbatim as they gave me, I went ahead and did this right at y1 plus y2. So here's my first function for y1, here's my second function for y2. And then what I did was I took advantage of the trig property that we saw in class. So the first thing I actually did here was I factored the 5 out of both of them. So that's where the 5 comes from. And I probably should have written the 5 out front to make this a little bit easier to see. Okay, but I factored the 5 out front, and then I took advantage of the sine of A plus sine of B trig property. And the rule there says, and again, bear with me because I can't write this down, but the sine of A plus sine of B would be 2, which is where this 2 comes from, times the cosine of A minus B divided by 2, which is what is represented here, and then times sine of A plus B divided by 2. Right, so that's one of our trig identities going back to some of your pre-calc work. It is helpful to remember that because it makes it a lot easier to figure out where this function is coming from, right? Rather than just blindly plugging into the equation. Makes it a lot easier to see what's going on. So anyway, as soon as I set that up, it actually cleans up pretty nicely, right? 2 times 5, obviously that's the 10 here. Cleaning up the inside of this, once I distribute the negative in, it actually cancels out both the x and the t variables from that first part of the function, right? So cosine of 0.25 pi over 2, this whole part right here is actually just a constant, right? And then I have sine of my function here as well. So looking through this, at this point, again, just cleaning things up a little bit more, right? So just plugging these values in and cleaning up a little bit more as I go, but simplifying here, dividing everything by 2, and then calculating the entire coefficient out here. So 10 times cosine of 0.125 pi, which gives me 9.24, which represents the amplitude of my resultant, my superposition function, right? So the 9.25, or excuse me, the 9.24, very easy to see where that comes from if I've used the trig identities to calculate this value here, right? 10 times cosine of 0.125 pi, and it gives me 9.24, right? Finding the frequency is also pretty easy, right, once I've represented my function using this term, because to find the frequency I can just use my omega the same way I normally would, right? So normally the equation says it's negative omega t. Well, that means then my omega is 1200 pi, and so omega equals 2 pi times frequency, so 1200 pi equals 2 pi frequency. Pi's obviously cancel out, divide both sides by 2, and that's how I got my frequency. So again, a more challenging problem, definitely one to where if you have any questions, let me know. This is something I would expect you to be comfortable setting up. The trig identity helps us get there without having to rely on those equations. So it is good to know this trig identity, but make sure you're comfortable with all the steps involved in this question. But anyway, that wraps up chapter 9.1 or homework 9.1 here. So if you do have any questions on this, let me know, but hopefully this video still helped out.